Hello, and welcome to Transform Tuesday. I'm Dave McCormick, VP of Product Management here at Alpha Software. And today on Alpha Transform, we're going to be doing basically an introduction to a multi-part discussion on the Internet of Things. So let's just dive right into it. Actually, before we dive into it, let me make sure that people can hear me and see my screen. I'm also joined here by Sarah Mitchell, our Director of Customer Success. Sarah, is everything coming through okay?
It is.
Awesome. Thanks very much. Okay, so Internet of Things. The Internet of Things is the interconnection via the Internet of computing devices embedded into everyday objects, enabling them to send and receive data. We've talked about the Internet of Things before. In fact, I did an example, let me see, I did an example back in June or July of 2020, if you want to look it up, in which I gave an example using TransForm to do a really simple operation, and that was to turn on and off a warning light. The idea would be that if, for example, some reading was taken out in the field or some data was collected out of the field that raised some sort of alarm that really had to be escalated, we had the transform thing actually switch on and off a light. So here's the picture of me without the light. Here's the one with the light, and it was all controlled using our form. Well, it was very serious last year, it seems. So anyway, it was the beginning of COVID, I guess. Excuse me. So how we did that was we actually had Transform Central wired into Zapier, something we've talked about in the past as sort of a workflow system that then connects to the Philips server, that then connects to the bridge inside my office, which is connected to the internet, and then that uses a wireless transmission, some proprietary thing, I guess, that goes over the electrical lines, to talk to the light bulb, where it can change the colors, it can turn it on, it can turn it off. And it was a really simple example, but it was kind of a cool little demo. But the Internet of Things can actually be used for a lot of more useful things than that. In fact, it's a huge enterprise. It slowed down a little bit last year during COVID, according to IDC. The growth was only 8.2%, but it's expected to be double digits for the next several years. It's already a 700, well, back in 2020, it was already a $740 billion enterprise. So the question is, what in the world are the advantages of using IoT? Why are people adopting this approach of embedding technology into objects and having them talk to computer systems? Well, probably the biggest thing has got to be driven by cost. And this is actually more so today than it was a couple years ago. Right now, we have a bit of a labor shortage, to put it lightly, at least here in the United States. So getting people to go out there and collect data and report it back is going to cost more money, and it's going to be harder to find people like that. On the other hand, if you have some sensors and a little computer out in the field, it can do this job for you. It could do it 24/7. It could do it in dangerous conditions. It could do it underwater. So, it's a much simpler way to collect things. And when I say cheaper, I mean some of these things you can have set up and going for under $100. I'm going to talk a little bit about that in a minute. All right, so let's talk a little bit about what goes into an IoT solution. There are really two parts. The first is, I'll give you a little preview there, sensors. Sensors are things that sort of observe the environment and can be used to report back on things. Sensors have become dirt cheap. This is actually a picture that I snagged and cropped from Amazon, where they're selling this package of all these different sensors, 37 different sensors, for about $35. So yes, sensors go for about $1 each, and they can detect everything you can imagine. This one does steam, soil moisture is another one. You can do knock switches, tilt switches. Obviously, you could do things like smoke and fire, but those are typically handled by dedicated fire alarm systems, so probably not the thing here. There's touch switches, there's passive infrared, and I'm going to talk about how that was used by one of our customers in a minute. There's also sound level, there's temperature, humidity, there's whether or not an area has flooded or not flooded. There's weight sensors, there's things that can detect whether or not a car is in a parking spot. There's just a million things that you can do that you may have an idea for yourself or for a client of how you can make their life a little easier by collecting and reporting back this type of information. But as you can see from these sensors, they are themselves not complete solutions. In fact, most of them have got like these four little wire probe things sticking out here. So the question is, how do you get information out of these little wire probe things into TransForm or something like TransForm, where you can actually see the data and organize it and put it to dashboards and things like that? Well, to do that, sensors, which are not by themselves smart, they just sense things, need to be connected to what's called to either a microcontroller or a microcomputer or some other circuit that then reads that signal and passes it back. So let's talk quickly about microcontrollers and microcomputers. Microcontrollers, such as this Arduino here, their job is basically what I've been discussing, which is sensors come in and a digital signal comes out. So they have analog to digital conversion as well as regular digital inputs. And what this lets you do is connect a wide range of sensors. And when something happens, you write a little piece of software that goes onto this Arduino board. You write it on your computer and you transfer it over with a cable. And it knows things to do. Now you can hook Arduinos up to Bluetooth devices and to Cat5 cables and things like that to communicate. And it's definitely a cool little system. I think I did a demo on one of those a couple years ago. In fact, I'm pretty sure I did, where we were using it with Bluetooth. Now, microcontrollers are great, but microcomputers, I think, are much better, because a microcomputer is in fact the full computer, meaning that if you wanted to, you can actually plug a monitor and a keyboard into it. It's got a full operating system like this Raspberry Pi, which I'm showing you here. We're going to talk a little bit more about the Raspberry Pi in a minute. But the Raspberry Pi is basically a full computer system. It boots up, you log into it and all that. One of the great things about the Raspberry Pi, besides the fact that it's way more powerful than just a simple microcontroller, is it's also almost as inexpensive as a microcontroller. A Raspberry Pi computer like this one, I think this is like the top of the line one at the time, the 4B. I think this one goes for about 40 something dollars. But Raspberry Pi computers are available in even smaller form factors. This one's about the size of a credit card, without as many CPUs, maybe with a little bit less RAM, but they go for as little as $5 for what's called the Pi Zero. And then there are some models. There are some models in between. I actually own several of them, and they're really cool little computers. So, what do you do with a microcontroller? So the question is, actually, let's talk about Raspberry Pi here for a second. And Eben Upton, I don't know if I butchered his name or not, but he is the founder of the Raspberry Pi Foundation. So 2 years ago, he said, wow, my Raspberry Pi numbers get stale fast. This is 2 years ago, so they're already stale. We sold our 30th million units sometime last week. So there are a lot. And since then, I believe Raspberry Pi has also gotten some investment money. So they're actually going to be even bigger. So that's there are a lot of these things out in the market. There's a huge amount of support for them. And you'll see why they're extremely useful. So let's back up just for a minute and talk I'm going to go back to advantages and just talk about a couple of examples that alpha customers have done when it comes to Internet of Things. The first one, you may have heard me tell this story before, but it has to do with a rat catcher, which I just love the tale of it. So basically, down in Australia, they have gigantic rats, and this person is working with a company whose job is to set traps in office buildings to catch rats. So after you catch a rat, of course, you need to go and empty the trap. So what they used to do is they would have a regular rotation where they would drive from building to building and they would check on all of the traps. Now, using an Internet of Things solution, the traps let them know in advance that, hey, it's time to come collect the trap because you have caught a rat in it, which saved a substantial amount of driving and a substantial amount of time and allowed them to provide better services. The other one, which is really quite an opposite scenario, has to do with a high-end office building in the UK. In this case, a company had a policy where sometimes people would work from home. Now, keep in mind, this is pre-COVID, where I know everyone worked from home, but back at the time, it was novel. And what they realized was because workers were only coming in maybe 2 or 3 days a week, they didn't need as much office space. So instead, what they did was they just basically had unassigned desks. You would come in and you would sit down with your notebook computer and you would work, kind of like a shared office space kind of arrangement. Now, office space in the UK or real estate in the UK is ridiculously expensive. So they really wanted to keep this office as small as they could, but they wanted to make sure that it was efficient. And this actually spanned multiple floors. What they didn't want to have happen is have employees come in and then spend 15 minutes, hunting and looking around and trying to see where there's a free spot. Instead, what they did was they built a map. So this map application would show them where the free spots were in the building. So how did it know there were free spots? Well, it was simple. What they did was they took a passive infrared detector, like the kind I just told you about, connected it to a Raspberry Pi, and they placed the infrared detector underneath each one of the desks. So when someone moved the chair or sat down, it would detect that there was someone there, and it would know on the map to mark that space as occupied. Once a certain amount of time has gone by without any movement whatsoever, it would decide that this space is now unoccupied, or it would also reset the next day. So there were a couple ways that it could clear. So this was also a huge a money saver in this case, because of the amount of office space that's being found. Now, really, what's limiting to IoT, I think right now, is imagination, because the technology is there, it's cheap, and it's easy. And if you've got imagination, I'm going to show you how we're going to put this all together over our next couple of webinars. All right, so let's get back into the presentation. All right, so what we're going to do is we're actually going to wire up, we're going to take a Raspberry Pi, and we're going to wire up 1 or 2, maybe 3 sensors to it. And we're going to have those sensors periodically, or when something happens, send a ticket to TransForm Central. It's actually going to fill in a ticket as if it were a person filling in their ticket on their phone for TransForm. So the way we're going to do that is by using, of course, the TransForm API. And we can access that API by connecting this device to the internet. You can connect a wireless card to it, and by writing a small piece of software. Now, Raspberry Pi supports multiple languages. You can program in C+ or C or whatever you want, basically. Whatever is available on Unix, you can program on it, which is pretty much every language. But the one that's tend to be preferred is Python. And Python is growing in popularity for quite a few reasons. It's used a lot in big data, along with a language called R. We're certainly integrating it more in Alpha because we know that not everyone knows how to program in XBasic if you're using Alpha anywhere. So using Python would be another good way to do server-side programming. It's definitely growing in popularity just as a language that people are learning, say, in school. One thing that, as Selwyn Ravens, our co-founder, pointed out when he was talking about our integration with Python is that it's a fairly easy language to master, mostly because it's a synchronous language, which is what a lot of people are used to. In other words, your commands operate in the order in which you expect them to. It is possible to do multi-threading with Python, but you usually don't need to do that. And we won't really be diving too deeply into Python code. We're just going to dive into enough of it to show you how to get this job done. The last thing I want to tell you about Python is, let me switch my Python slide, is that it was actually named for Monty Python. I guess the designer was a huge fan. A little bit of trivia there. Okay, so here's sort of an example Python script. I'm not going to dig too far into it, mostly because I don't have it working right now, but it will be by the next time I show it to you. And so what I'm going to do is I'm going to introduce you to, over the next session or two, to the Raspberry Pi computer. I'm going to introduce you to Python, as well as IDLE, which is the IDE that you are often used for, or the editor that's often used for creating Python software. And we're going to put together a complete system. So I hope you will join us for that. I think this is the end. Yep, it is. This is the end of our presentation, but I hope to see you guys back. So just a quick question out there. Is this the sort of thing that you all would find interesting to cover? I know there's been some interest in IoT in the past, so I'm just sort of getting a gauge because I know that the people here are definitely our TransForm fans. Oh, okay, good. I'm seeing a little feedback there. Great. Well, I will definitely cover it. And if you have ideas for other TransForm Tuesdays, we are putting together our editorial schedule for the next fiscal year here, and I want to make sure that we cover everything that you would like to see. Cool. Actually, great. We have a whole bunch of yes, cool, sounds cool, awesome. Well, I think you're really going to enjoy this. Thanks very much for joining us today. We'll see you next week for another TransForm Tuesday. Take care and stay well. Bye-bye.